So how does this work? Let me try to explain it all. Well, the end result, the digital version, the digital result is to produce a SVG file. A SVG file is a vectorial image which contains all the curves, all the strokes to do, all the letters. So it's a pretty simple format that consists of having a lot of positions. So all the curves are encoded in with points, like absolute points, but also localized points. Anyway, it's using either you can do line 2, or you can do Bezier curves. In my case, I only use ISO lines, so that means it's just a bunch of positions, move to, and yeah, so quite classical, quite simple things. So there's so many curves here on that plot that the SVG file is about 31 megabytes. So yeah, quite intense. That's why it took 5 minutes or something like that to start at the beginning to warm up, because it's huge. When you look at it, looks like that actually. What I did just for myself, it's not very important. You can encode everything in a big array of points, but I have split it into different layers so I can easily, if imagine if there were an issue, I could easily start from a specific word. Anyway, there's like 5,000 words to draw, and each word is somewhere and is at huge list of points. So it's like never ending. You can see the size here. Yeah, quite huge. So we have like positions. Anyway, that's what's getting generated at the end. But before that, well, I'm gonna try now to explain the code. So let me check. It's I don't have a lot of space just above me. I'm gonna try to use that efficiently. So exactly like last time, I already shared that on Twitch in the past, but let me try to show what I use as a primitive. The only asset I have, again, is my bunch of, oops, not that, not a lémurien, my bunch of letters. So in Inkscape, I have used my tablet, my graphic tablet here so I drew on my graphic tablet letter by letter to just draw very ugly letters like that. So from A to Z, let's hide that text. From A to Z and underscore because we are like, this is for username on Twitter, and underscore is allowed. And from 0 to 9, so all the digits. Oh, you see, it started the inside. Nice. So we are quite close to the end. The goal was to make sure we can everything is only one curve. Even the T is only one curve. You can see here how it works. It's a bit a hack. But yeah, everything is one curve except the I and J where you have the dot. This is why it's going to have to do the dot before or after. It's a bit weird why it's doing it before, but anyway, that still works. So first important part is, okay, one curve. But then second important part is to try to make sure the thing is more or less of the same scale, a bit aligned and everything. Anyway, it's not very precise what I did here. In any case, at the end, we are only having letters of 2 millimeters on the paper. Like this height here is going to be 2 millimeters. So it's very, very small. One letter is actually even less. So maybe one letter is just 1 millimeter. Yeah, that's very, very tiny. We don't even going to see the imprecision of these letters I did here. But it's nice. I have a letter.svg file, which is my font in a way. And I could do another one, and the whole code will still work. So I have splitted the font part away from the actual code, and the actual code is going to try to attach the letters to make words. That's the main point of that. To make to actually draw the words. So this is again a very generical framework I did. Well, first of all, I need to import that SVG file we just saw, and it's quite simple. We just have to parse the SVG, extract the path, and I use a library called isvg2 polyline in order to extract, to convert the curves to isolines. So yeah, you need these kind of libraries for sure, or you have to implement yourself, but nothing very big at that point. I just have what I call a letter referential, which allows me to render any letter by its code. So I can get a letter and render it. On a letter, you have a render function, which takes a position, a size, and this is not even used anymore. I have to clean up some code. Then the main part happens on the generator itself. So the generator is doing many things. Okay, maybe let's start in order. So, well, I have a big, huge part of arguments here, which is like have default values. So this can be tweaked. I tweak them, all the values to try to adjust. Like the font size is actually 2.03 millimeter, and just a tiny change of that number were like fine-tuning stuff. So that's what I did at the end. So for all the variables, instead of having constant in my code, I will just put them as a parameter. And yeah, that's quite useful. If you need to run 10 different versions, you just tweak, you just try with different parameters, and that's gonna ease everything. So the main function of that program, it's a Rust program, right? And what does the main function do? Do I have a word wrap? Yes, I have. Okay, I'm making sure you can see everything because that's very small. So what is the main function doing? Well, I need a Twitter API to fetch all the followers. So I did run it once when I was exactly at 5,000 yesterday. And this is generating, so it fetches from the API, paginated API, all the followers, and save it to a file, followers.txt. And if the file is here, we are not going to fetch it again, so we directly are going to go to the next step, which is drawing the art. And that's the main function here I'm going to move to now. Also, I'm loading the letter referential I just explained and pass it to the art, so it can render fonts. It can render words. Not words, only letters. It can only render letter by letter. We will see how we render words soon. Okay, and I try to comment the code. I'm going to publish it after as well on my website as usual. But yeah, let me continue commenting it. So, I forgot about that. I thought it was in order, but it's not in order. I'm not sure why I kept that, but why not? I'm sorting the username by length. So that's why at the beginning we saw Vega, because it's only four characters. I mean, we saw all the usernames that are a few characters at the beginning of the plot. So all the username with a few characters are the one near the white area we see here. So the first exclusion away from the inside was made with these small usernames, and more we progress in that, bigger the usernames are. So that's a way for you to locate yourself, because the goal at some point will be for everyone to see where they are. But yeah, meanwhile, I think when it's not when the username is the same, it's probably in order of following, I guess. But that does not really help locating yourself because it can be any places as it's doing a circle thing. Anyway, not really important. Okay, so let's move on. I need an image. I need an image for having it's like this is actually the second asset. Is this image that I did with the Twitter logo and 5K. So it's a very simple image that I used to look up to know to locate the logo and the text. But as you can see, I'm not drawing it straight away. I need to analyze it to detect the edge and grow the distance away from the edge. How do I do that? Well, I think I'm doing it right now in the code. So I think it's the beginning of the code is going to fill what I call a value map, and it's going to calculate the curves. So I have a function that allows me to pick any color of that image for a given x and y coordinate. And I'm just normalizing it depending on the canvas size here. I think it's a bit stretched because I use width and I don't use the padding we have, but we don't see it because it's very big. Okay, so what I call a value map is a value for like the whole space is going to have a value from like I think it's it's an integer value, so like 0, 1, 2, 3. So for any position in the canvas, I assign a value with and the value map has some precision. So for instance, if we have a precision of, I think we have 0.4. Yeah, we have 0.4 millimeter. So that means every 0.4 millimeter, we have one cell of that big grid. And in that big grid, I will store 0 and 1s. Ones means we are darker than white. I mean, I'm not even sure why I did that, but I think in any case, it's going to put 1 when there is dark. So I guess that means when it's outside. So yeah, 0 is going to be the logo and the 5K, and 1 is going to be outside. So that's why I can just differentiate if it's inside or outside. And then I'm going to use contour detection. Contour detection is made with an algorithm called Marching Squares. But I also do another value map for the outside. So the inside and the outside is two different value maps because I'm going to reuse the value map. An algorithm, I don't even know what it's called, but this idea to grow the pixels. So it's like you can make it sharper, or like you can make it expand. Like when you have like an area of white color, you want to expand it, like its limits. So I've made a quick code that will just do that. And that's what I called grow. So yeah, I have a loop. This part is a bit complex, but actually not that complex. But it's the important part that is going to infer all the curves. So I could even, I think I could even showcase it. Hold on, I'm going to save the code to not mess it up, to make sure I still have it later. Okay. So let's put the precision back up so we can have a quick rendering. And I'm going to enable the debug mode. I don't know how to do that. Oh no. Yeah, I think it's minus debug on the command line. Tac. Is this working? Okay. So when I activate the debug mode, you can see that, oops, we can see that we have all the curves. So I can open in Inkscape. Maybe it's going to be easier. Right. So yeah, it's very dense. So, and it's very laggy on Inkscape. But yeah, at the beginning, I had to make sure we don't have any useless curves. So I've made a few modification of that. You can see it's actually, it's not very smooth. It's not doing like a smooth turn. It's actually doing lines because I didn't want all the letters to, all the words to like always like shaking angles. So it needs to follow some kind of lines to make it to be more readable. And that's what is done with, so I used what I call RDP. The RDP function is implementing Ramer-Douglas-Pucker algorithm, which allows to simplify a curve by doing lines that are more or less following the curve. Yeah, you can Google that if you want to see exactly how it works. So I use that, and I use another code, another algorithm I did here. It's a bit my own algorithm here, but it's a very simple idea to slice the path into multiple paths. So I want to cut my lines, my curve every time there is a too sharp vertex. So every time there were a vertex sharper than a corner, like that 90 degrees thing, I was cutting and creating two different paths. That way, this was to make sure there is no word that is doing a very angular turn. And that was very important because I had glitches before that. I had many problems like that, where we were seeing a huge seams. Like it was not seamless. I mean, we were seeing the seams, SEAM, like all the I don't know, like all the parts where we have big turns. So here you can see not a lot of words are getting drawn because as I decrease the precision, we have issues with collision. Anyway, that's what I did a bit later on that code. So anyway, we have a loop that is growing the area. So the area starts with the logo and then is making different levels of ISO lines, like cartography. Like in cartography, you have different levels. And yeah, this is what this grow is doing. It's growing the pixels away with some radius. And the inside has more radius than the outside, like have more padding. So we have a lighter area, like we can see right now on the stream. Okay, so that was just to calculate the curves. At the end, that's what I'm drawing here in debug mode. Okay, let me undo the precision change. Okay. So once we have the curves, now we can use them to place words. And it starts here. So I need another value map, a more precise value map to do collision. So a value map, this idea of having a grid of values from 0, 1, can be used to, it's like a mask, can be used as a mask to do collision detection. So every time I put a word, I will take the curve small curve under the word and store a 1 along the grid of that mask. And if there were already a 1, that means there is a collision, and that means I cannot even place the word. So that's how I do collision here very efficiently. It's very efficient to do it that way with a mask. So we have a main loop that is going to iterate over all the possible curves here. All the main lines we have all around the plot. So indeed, at the end, I'm not even drawing the lines. These are just used to know how to place the words. So that's why we iterate on curve, but we don't draw them. We only then are going to iterate on words. So for each curve, we try to place as much word as we can. And that's what we do here. We have a first step here that is going to calculate how much words we can place, and it's going to sum the distance every time. We have two sums. We have the sum of the space to take and the sum of the words that are like the measurement of the text. And when you do the difference of the two, of the total length with the sum of the words, then you can calculate the padding between each word, so we can we can balance the words on the curve. And this is a very important part to make sure everything is well distributed in terms of density. And it's almost a win when you look at the current plot, except small parts where we couldn't even place a word because it was like a triangle or something like that. But apart from that, everything works smoothly. So for every text to draw, every word, every username, I'm calling a draw text function. So this is like the big function that is able to draw a text. And it's only taking a few parameters. It's taking indeed the text to draw, the letter referential, the size, the font size, and then we have a path. So it's going to project the word on a specific part of that path, and you actually have to define also the X start. So where on that path do you start the word? If it's at 0, it's going to start straight away at the beginning of the path. But if you do, 10 centimeters later, but then it's going to have to calculate the offset. We also can project the word away from the path or inside out. It's very, very similar to if you played with Blender when you want to make an object follow a 3D path, a 3D line. You can actually do exactly the same things. And I had that in mind when I developed that. So the draw text, very, very simple interface. And it's going to return all the strokes to do, and it's going to return also the length of the word, because it's always useful to know how much width we have for the whole word. For the whole word. Okay, so this is one of the not that crazy, but it's a bit complex algorithm here. We have to iterate on each character of the text indeed, and then for each character we are going to try to see if we can attach the path of the letter back to the previous letter. But it's only when we have the letter that is attachable, because not all the letters are able to connect. Like the digits are not meant to be connected in my current case. And unfortunately, it's a bit hard-coded in my framework, but we could have a way to differentiate between that in the future. It's very simple actually until I had to do some tweaks. It was very simple until I had to do some weird hacks. Not really hacks, but I have to interpolate the curve to sometimes attach it a bit more smoothly. And one example I shared last stream on Wednesday, I think, was the V, the W, and the O, and the letter O. And we actually did it live in a stream it was on Wednesday. So you see the O ends with like way higher than the most of the letters. So when we want to attach another letter after that, we have to raise it like that. And so I needed to do some code for that. I'm not going to do again all the letters just because we have a letter that needs that. So indeed, I took a simple path to just interpolate the position. Oh, by the way, at that point, imagine you can use the RNG. You can totally tweak the positions of every letters and produce randomness in the letters as well, like making every letter unique. This is something that could be interesting to do as well, but I didn't. In any case, that works quite smoothly after we fix that. So yeah, we connect the two letters here anyway. And at some point we can, so yeah, we have an exception on I and J as well, because they are not going to connect with the previous letter. They are going to be extra lines to draw. This is why we have an array of paths and not just one path. So yeah, at the beginning we just like place all the letters together on horizontally, and then we project. And the projection part works in the second part of the code. So it's at the end the code is quite elegant. For every point of every path, I'm literally projecting them all along the path you provide as a parameter and following the X start that was defined. So I look up my XY coordinate on the curve, and then I need to project with the normal vector the Y coordinate, and finally we can calculate the position and push it in the projected path. So yeah, the lookup curve point and angle function is a bit below here. It's a bit noisy code, but it's quite simple at the end. It's just exploring the path and counting how much distance has been progressed along that path to locate exactly where do you want to. Which point do you want to take? So it's only looking up one point at a given. I think there's a native JavaScript function on SVG for that, by the way, like calculate the point for a given X value. But here I'm just using Rust from 0, so. But anyway, it's not so complex at the end. So all of that just to draw one word. But now we have a very generic function. I used to do like rotation, translation, rotation, but here it's even more generic. You can do anything because you can follow any curve. So you can do one line that is going to do a translation, or you can do a rotated line, which is doing a translated rotated, but you can also do a curve. So yeah, everything is possible after that. So then here we have a phase where we do the collision I explained with the mask. And if we have a collision, we are going to push back the word into the list. So there is no guarantee we will consume all the words if there is not enough space. That's why I have logged here if in case when I was developing it to try to fine tune what was the correct font size to do. And every time I was tweaking some algorithm, it was always changing. So I had to make sure all the words are used. And I think that's it. We saw everything. There's nothing more. So to summarize, we have a combination of multiple algorithms. We use two assets. We use an asset that contains all the letters. We use that I drew myself, and then we have also the image itself. From that image, we are detecting the contours at multiple levels. So we are projecting the distance function in a way with matching squares. We can, with the distance function to the contour of the logo, we can calculate all the curves. And with all the curves, we will project words. But before projecting words, we have to make sure there is no Sharpie curves. So we cut the curves into pieces to remove any sharp angle. We also optimize the curve to avoid a very noisy curve, because that will make the word go crazy and make it very unreadable. So all of that is to secure the readability of every word. And after that, we can just try to find places for all the words. So we iterate on curves, trying to find, making sure the padding is the same between words. There is no global padding between words, by the way, but we try to... so that means there's no... the padding is variable all over the piece, and you can actually see it. You can also sometimes see some hole, some white hole at some places, even on a regular curve. I'm not talking about the triangle issues, but this is part of the trade-offs. You cannot really make it follow the curve of the logo and also follow the border of the canvas. So you need to do a transition between the two, and that means some padding need to happen at some places. Here was one way to do it. I had a few ways to do it before that one. I did a few iterations. I don't know if I kept it. Maybe this one was a very old one. Hold on, I'm going to try to open it. So you see, I had this other possibility. I could show all the previous prototypes I had. Some were very, very ugly. But this was... if we would project equally from the edges and from the inside, and at some point they are going to meet, and they are going to make very ugly seams like that. In a way, it's nice. It's a bit cool. There's a cool style that emerged from that. It's like a TV display, but the trade-off, the counterpart is that we it makes the high go, you I don't know how to explain that, but it's noise to me. This is not the important part to have that. We want the logo to be more visible, so I prefer the current one we have, which is a bit more balanced. We don't have in the middle of that part, we don't have any glitch. It's just a bit spreaded on the outside. So usually it's when we reach the border that we have that glitch. I could have removed the external border, but I find it cool to still display it. So that works. Anyway, I think I explained it all. So that's gonna be fun to photograph at the end. That's gonna be challenging for everyone to locate where they are on that big canvas, but that's gonna be fun. So we can see here the inside have very long usernames. So if you have a very long username, you may find yourself on the inside and not on the outside. At the beginning of the outside part, we have the smallest usernames. And when we reach the edges, it's the middle size. So it's 7 characters long. And the inside is very long usernames. I actually forgot about that rule I did, but it's actually a good idea because I like the fact we use long names to make the logo. I think it works even better. Because anyway, the inside is going to have more padding, so that's makes it more balanced. Like really like the fact the logo is even more enhanced with that orientation here. So that's cool. To me, everything is good. And this was not even the current version we have right now. The version we have right now is even lighter. Like the inside have even more padding. So yeah, that's gonna be cool.